Okay, good morning, Professor David J. De Los Reyes. It's September 11. The time is 2:37 a.m. Okay, my topic for this session will be a long video format discussion on college algebra. Okay, for those who are following my channels, we are running smooth. We are now on lesson number 58. Lesson number 58. We are almost done with college algebra. Okay, so the topic for tonight will be college algebra lesson number 58, and the title of the topic is binomial theorem, art term problem. We will be solving a problem involving the art term formula. Art term or end term formula. Meaning, if we are given the expansion of the binomial, if the problem is asking for the end term or art term, okay, we could solve for that one by using one of the formulas under binomial theorem, or to check the validity of our answer, we could use Pascal's triangle to solve for the end term or art term. Okay, let's proceed. I will try to give you an example problem. I will try to read the problem. Find the third term of the binomial expression, the quantity 2 plus 3 raised to the 6th power. I place a binomial number here, so actually we could visualize if the validity of our formulas are actually correct. Meaning, if we try to use our formula, we will be bringing out an answer, and the answer should be in terms of numbers, right? So it is much more fun if we could, if the answer is a number, so when we check it, it is still a number, and they are the same. We are really correct in presenting those two answers that are to be correct. Okay, let's proceed. To bring out the third term of the given binomial 2 plus 3 raised to the 6th power, okay, if we try to expand this binomial here, the total number of terms is actually 7, right? Because the total number of expansion from our concept, it will be n plus 1. So if n is equal to 6, the total number of expansion is actually 7. And the problem is asking what will be the third term, right? So to bring out the third term, I will remove my eyeglass. Still looks fine, you know. We got a formula under binomial theorem. The art term or n term is actually equal to, this is the given formula. A little bit long, right? It is n factorial. The resulting coefficient of the answer should be n factorial all over the quantity r minus 1 factorial times the quantity n minus r minus 1 factorial. Okay? This is r minus 1 and this is r minus 1, meaning this in here, we will subtract a value, the quantity r minus 1 factorial. And the resulting first term, it will be a raised to n minus r minus 1, b raised to r minus 1. The sum of these, okay, should be equal to the given value n equal to 6. Right, because a minus open quantity r minus 1 plus r minus 1 is actually 0. So if we try to add the exponent of a and b, it will come out to be equal to n. Okay? Let's try to bring out the solution. Since we are now given this formula, supposing you are on the SAT exam and you forgot the formula, so you'll have a problem, right? For me, I will not have a problem. Why? Well, I know Pascal's triangle, right? I will just construct the Pascal's triangle. Then I will construct up to n is equal to 6. Okay, and since we know that the total number of expansions is actually 7, this is 1, 2, 3, 4, 5, 6, 7. This is actually the one the problem is asking for, the coefficient. So if we know the coefficient, okay, we could come out with the multiplier, the first term raised to a certain exponent, second term raised to the exponent, and that will be the answer, right? But by using this formula, this should be the formula. So if n is equal to 6, r will be 3. R will be 3. It's the r term, right? We will compute for r minus 1. We need an r minus 1 over here. R minus 1 will be 3 minus 1 because r is 3, right? So r minus 1 will be equal to 3 minus 1 and that will be equal to 2. Okay? We will compute for the value n minus open quantity r minus 1. N is 6. The value r minus 1 is actually 2. So this is minus 2 and this should be equal to 4. Right? So this r minus 1 should have a value 2. And the value of this quantity here, n minus quantity r minus 1 is actually 4. And this n here is actually 6. So if we try to compute now for the, what they call this, r term now will be, since r is equal to 3, the third term is equal to, by following this formula here, it should be 6 factorial, which is n factorial. R minus 1 is 2, so this will become 2 factorial. The difference of this is 4, so this will be multiplied by 4 factorial. Multiplied by, the first term is 2, right? So this is 2. So how do we know the power of 2 here, the first term? You just start here. This will be the first term, so the highest number of the value of n is actually 6, right? So the exponent of x here will be 6, exponent of x here will be 5, and the exponent of x here on the third term should be 4. So the first term will be actually the first term raised to the fourth power. And since we know that this is to the fourth power, okay, the second term, which is 3, it should be n minus 4, or that will be 6 minus 4, so it will be 2. Because the sum of the exponent of the first and second at any moment will be equal to n, and the 4 plus 2 is equal to 6. So this is correct. The exponent of 2 will be 4, and the exponent of 3 will be 2. So simplifying this one, 6 factorial is actually easy money, right? O easy one. Madali lang, CCU in Tagalog, right? 6 times 5 times 4 times 3 times 2 times 1, that is 6 factorial, all over. 2 factorial will be 2 times 1, and 4 factorial will be 4 times 3 times 2 times 1. Okay, then try to make some cancellations. I think the whole 4, 3, 2, 1 will cancel. Right? 4, 3, 2, 1 will cancel. What's next? These 2 here cancel with this 6 here. This will become 3. So what remains as a coefficient will be 3 times 5, and then that will be 15. And 2 to the 4th power is actually 16. And 3 squared is actually 9. So this will become 16 times 9. The coefficient is actually 15. It's 15. Right? It come out 15. So if we try to multiply all this, I want the answer to be just a pure number. So when we check the validity, we know that it is correct. Right? So this will be 2160. Meaning, if we try to expand this one, the third value here with the coefficient of 15 is actually 2160. Okay? So, how do we check the validity of our answer? Am I still on camera? Right. We use the Pascal's triangle. We construct the Pascal's triangle, right? The value of n here is actually equal to 6. So we will construct a Pascal's triangle up to n is equal to 6. So the top portion will be 1. Next will be 1 and 1. Next row will be 1 plus 1 is 2. The 2 parents will be 1 and 1. 2 parents will be 1 again, but the two middle terms will be, this is 1 plus 2, this is 3, and 2 plus 1 is 3. Next row, the 2 parents will be 1. Okay, the 3 middle terms will be, this is 1 plus 3, this is 4. 3 plus 3 will be 6. 3 plus 1 will be 4. Per n will be 1. Right? That's for n is equal to 4. Next row. 2 per n's will be 1. Okay, for n equal to 5, there will be 6 terms, right? So the middle terms will be 4. And the coefficients are this. 1 in 4 will be 5. 4 in 6 will be 10. 6 in 4 will be 10. 4 in 1 will be 5. And this is 1 again. For n is equal to 6, there will be 7 terms, right? So the 2 per n's will be 1. And the middle terms inside, the terms inside will be 5, right? This is 1, 2, 3, 4, 5. So if we try to bring out the coefficient, this is 1, so 1 plus 5 is 6. 5 plus 10 will be 15. 10 and 10 will be 20. 10 and 5 will be 15. 5 and 1 will be 6. And this is 1. That is for n is equal to 6. Right? So if we try to count starting from the left, this is the third term. First, second, third, fourth, fifth, sixth, seventh. Okay? This is the coefficient of the third term. So if we now try to bring out the third term by using Pascal's, it will be this coefficient here. Right? Like on the first solution, the first term should be 2. And the exponent will be 4. This is because this is 6. The power of x here is 6. Here it's 5. The power of x here on the third term will be 4. So this is 2 to the 4th power. So if this is 4, okay, obviously the exponent of the second term, which is 3, will be 2 because 4 plus 2 is actually equal to 6. So just the same as in the first solution, this will be 15. 2 square will be 2 to the 4th is 16. 3 square is 9. And if we try to multiply this one, the total value will be 2,160. Just simply 2,160. So this 2160 is same as this. Hallelujah. Okay, we brought out the validity check on the validity of the derived answer, which is 2160. Because this answer 2160 actually was computed by using the formula for taking the R term. That is, it should be an n factorial, a little bit long, over R1 minus 1 factorial times the quantity n minus R minus 1 factorial, a raised to n minus R minus 1 times b raised to R minus 1. So, in the computation of the R term, it's a must that we should memorize this one. Right? But you don't have to memorize this one. As long as you know the power triangle or the Pascal's triangle, we could bring out the third term by just constructing a Pascal's triangle up to n is equal to 6. We got a problem. If the value of n is 100, there's a problem. Right? We don't have any remedy for the check of the validity. We must have to use the formula. But in here, since n is actually reachable by using the Pascal's triangle, there will be no problem, right? And actually, we have brought out that the third term is the same as 2160. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.